You know, in school, we're all taught a pretty simple story about Earth's magnetic field. It comes from the churning, molten core, right? Well, what if that's not the whole story? We're about to dive into a radical new idea, a hypothesis that could totally flip what we thought we knew about our planet's most important defense system. So, why do we even care? Well, this gorgeous, invisible bubble around our planet is basically a force field. It's constantly batting away a deadly stream of charged particles from the sun. Seriously, without it, the solar wind would just strip our atmosphere away. Life as we know it, it just couldn't exist. But here's where it gets interesting. That feeling of a stable, reliable shield, it's kinda an illusion. And its wild, unpredictable nature opens up this huge scientific mystery, one that really makes us question if we understand how planets work at all. Okay, so to get why this new theory is such a big deal, we first have to talk about just how shaky our magnetic shield really is. And believe it or not, the story is written right into the rocks beneath our feet. First off, our magnetic poles are not fixed points. They're constantly drifting around. But way more dramatically, every once in a while, they just completely swap places. Yeah, north becomes south, south becomes north. It's a full-on magnetic reversal. So how on earth do we know this has happened? The proof is actually lying on the ocean floor. See, as new crust forms and magma cools, the little iron bits inside it line up with Earth's magnetic field at that very moment, kind of freezing a snapshot of its direction. The seafloor is literally like a giant tape recorder, documenting every single one of these flips over millions of years. And that geologic tape, it tells an absolutely incredible story. In just the last 83 million years, the poles have reversed 183 times. Let that sink in. This isn't some super rare thing. It's a chaotic, but totally fundamental part of how our planet behaves. Okay, so what's the official explanation for all this? Well, for decades, the answer you'd find in pretty much every textbook has been something called the geodynamo theory. The basic idea here is that as the Earth spins, it organizes all that churning liquid iron in the outer core into these massive spiraling columns. And this whole setup, this motion, basically turns the core into a gigantic, self-powering electrical generator, a dynamo. Just picture it. These huge, flowing currents of liquid metal create electric currents, and those electric currents generate the magnetic field. It's a really elegant idea, and it's been the cornerstone of geophysics for a long, long time. But, and this is a big but, it isn't a perfect theory. Actually, when we start looking around our own solar system, we find some major puzzles that the geodynamo model just can't seem to explain. It's got some pretty serious cracks in its foundation. Puzzle number 1. Let's go back to those 183 flips. The geodynamo theory really struggles to give a clear reason for why they happen. How does this huge, stable, spinning system just spontaneously decide to reverse itself? The actual how is still a huge question mark. Next up, the puzzle of Mercury. It's a tiny planet, so its core probably cooled down and solidified a long time ago. But wait, if there's no churning liquid core, the dynamo can't work. And yet, Mercury has a magnetic field. How is that even possible? And the problems only get weirder as we go farther out. This number, 59 degrees, that's the tilt of Uranus's magnetic axis compared to the axis it spins on. That's not a little wobble, that's a massive, staggering tilt. See, the whole point of the geodynamo is that it's driven by rotation, so the magnetic field should line up pretty well with the planet's spin. But for Uranus and Neptune, the fields are just wild. They're tilted like crazy, and they're not even centered in the planet. This just completely breaks the logic of the theory. Okay, so we've got a leading theory with some major holes in it. And this is where a brand new, pretty radical idea comes into play. It suggests a totally different source for planetary magnetism: superconductors. The key idea from researcher Jerry Z. Liu is right here in this quote. We need to stop thinking about superconductors as some weird, exotic thing we only make in labs. The argument is that at the insane pressures you find deep inside a planet, they're probably a totally normal, even expected state of matter. And this chart shows us why. See, up here in room conditions, where we live, materials are usually conductors or insulators. But when you crank the pressure way, way up, like deep inside a planet, the rules of physics change. That blue zone shows superconductivity becoming a totally stable, normal state. So the new theory goes like this. Superconducting materials floating around the outer core get swept up by the planet's rotation into a stable, continuous belt or loop. Now, a superconductor has zero electrical resistance. That means an electric current, once you start it, could flow through this loop forever without losing any energy. And that perpetual current would generate a super powerful and steady magnetic field. So the big question is, does this new suspect actually solve our cosmic mysteries? Well, this is where it gets really compelling. Let's see how the superconductor model stacks up against the puzzles that the geodynamo couldn't crack. First, those magnetic flips. The superconductor theory offers a beautifully simple physical reason. Strong currents in the core can literally just break the loop. The field collapses. Then, the planet's rotation pulls the pieces back together. And depending on how things are aligned at that moment, the current can restart in the opposite direction. And just like that, you get a flip. What about Mercury's mystery field? Well, the geodynamo fails because the core is solid. But for the superconductor theory, that's not a problem at all. The loop could have formed way back when Mercury's core was still molten, and then it just got frozen in place as the planet cooled. It's a relic, a perfectly preserved ancient magnetic field. And this same logic gives us a stunningly simple answer for the bizarre fields of Uranus and Neptune. Their superconductor loops probably formed and solidified early on, lined up with their original spin. Then, much later, some massive object could have slammed into the planet, knocking it over and changing its spin axis, but leaving that ancient, frozen-in magnetic field pointing exactly where it always had. You know, if this idea holds up, it really reframes how we think about the guts of a planet. The magnetic fields we see might not be churning away being generated today. They could be these incredibly stable, ancient structures that have been preserved for billions of years. And that leaves us with one last, pretty mind-bending question to think about. Could this single, elegant idea, superconductivity under pressure, be the unified key that finally unlocks the magnetic mysteries of not just Earth, but of Mercury, the ice giants, and maybe even countless other planets all across the galaxy?